This is the cell respiration experiment that can be found in both the Biology with Vernier and the Advanced Biology with Vernier lab manuals. It's a popular experiment for general biology and one of the required experiments for AP biology. In this experiment, we will be using both a CO2, carbon dioxide gas sensor, and an O2, or oxygen gas sensor, to measure the amount of CO2 that's produced by germinating peas and the amount of O2 that's consumed by the peas. One nice thing about this experiment is that it can be performed in 10 minutes, as opposed to the lengthy experiment required by traditional methods. I have some peas that have been soaking for a few days and have started to germinate. Measure out 20 to 25 peas and place them in the respiration chamber. Put your sensors into the biochamber. Now, this is a biochamber 250 that allows you to use both the CO2 and the O2 sensors at the same time. I'm going to put the oxygen gas sensor into the top of the biochamber and the CO2 gas sensor into the neck of the biochamber. Carbon dioxide gas is heavy and will lay down towards the bottom of the vessel. This orientation will allow you to pick up the CO2 earlier. Connect the sensors to any of the 4 ports on the top of LabQuest. When LoggerPro is opened, the sensors auto-ID and set up some default data collection parameters. Notice that the CO2 gas sensor is measuring in parts per million, and the oxygen gas sensor is measuring in % oxygen. For this particular experiment, we need to open an experiment file. To do this, go to File, Open, click Biology with Vernier, and choose Experiment 11D. Notice that the units that are used to measure have now been reset to parts per thousand for both the CO2 and the oxygen gas sensor. The CO2 gas sensor has a 90-second warm-up period, so wait at least 90 seconds to begin data collection. After 90 seconds, watch the CO2 levels to see that they're starting to increase. If they are, start data collection. When data collection is finished after 10 minutes, remove your sensors from the biochamber and pour out the peas. Flush out your bottle with water to remove any remaining CO2. To determine the rate of respiration for the peas, we'll need to fit a linear fit to our data. Click on the top graph, the CO2 graph, to select it. Click on Linear Fit on the toolbar and record the slope in your data table. This is the rate of CO2 production for the germinating peas. Similarly, repeat this process for the oxygen gas graph. As you can see, the graphs clearly indicate that carbon dioxide is being produced and that oxygen is being consumed while the peas are in the respiration chamber. Some variations on this experiment could include investigating the effect of temperature or the number of peas on the rate of respiration. This experiment lends itself very nicely to inquiry.